All right, so let's talk for a minute about functions. Functions are going to be integral into what we do here in physics and in the math that we do. So let's go ahead and define this a little bit. A function is some relationship that defines a situation in terms of a set of interacting conditions. And I guess what I want to get you to understand in this video is it's really easier to think about what a function does rather than trying to define what it is particularly. And I've got a little graphic that I want to show you that will hopefully help you understand what I'm trying to say there. If you remember the earlier video when we talked about how math and science are related, we talked about these real-world events. And if we look at this, the real-world events, you remember, are defined by those fundamental dimensions. And if we click on this and take a look at it, try to remember that those fundamental dimensions were mass, length, time, electric current, temperature, amount in moles, and luminosity. And at this point, the purpose of this video is to remind you that these fundamental dimensions interact in different ways, and that's what we study. We find the interesting ways that these dimensions, what their relationships are. So when these dimensions interact, that is sort of the definition of what a function is. And I'm going to break away from this and come back and let's think about, well, what do I mean by the interaction between these dimensions? As I said, it's really easier to think about what a function does more so than what it actually is. And if we've got this box, this widget here, that let's put some labels on here. Let's say that this box has an input side, and then it's got an output side. And so what I'm trying to tell you is that we put things in here, and then we're going to get stuff out there. So maybe there's some relationship. Maybe there's some relationship that we find between, let's say, volume and mass. And so I guess what I'm trying to say, to try to make this make a little bit of sense here, what if we have some object that has a volume of 3 cubic centimeters, and we put it into this box? Then what it's going to tell us is we're going to get an output. It's going to tell us what the mass of the object is going to be. Maybe the mass of an object, would be 9 grams or something, whatever it is you put a number in one side and it gives you a number out on the other side. And we're going to talk a whole lot more about functions later, but what I'm trying to point out is that we're defining some relationship here. There's a relationship between volume and mass that we sometimes study in science. We call it density. And it's defined by a function. So now if we go back and look here, these functions that we talked about, let's take a look at them real quick. So these functions have some common shapes. You probably remember those from your earlier math classes. We've got linear shapes and quadratic shapes and logarithmic shapes, inverse shapes, all those sorts of things that when we graph functions. And in physics, what's really cool, when we graph these functions, that's where we get these derived units that we talk about so much. And it's why I'm pointing this out. If we learn the relationships, the units are something we don't have to memorize necessarily. So a function could be between length and time, so speeds meters per second. And density is some relationship between mass and volume. Force is some relationship between mass and acceleration. And so we get derived units from that. And I hope the point of this is to just let you know where things are coming from. And if you know where they're coming from and how we're getting this stuff, maybe it's less scary. So this function that we have was a relationship. The formulas that we use in the math and the physics are just representations of the function, and these functions are represented graphically, and we're going to do all of those things. We'll talk a little bit later about the ladder of abstraction and how we're going to move from between these different ways of representing relationships. But for now, that's what I want you to understand about a function. They're not scary things. They're just definitions of relationships. I'm going to go ahead and throw this into this video here. We've had several short videos that we've looked at in our introductory series. And just to summarize, we make observations of the real world. We find situations that are interesting to us, and we decide the questions that we want to ask and the things that we think we need to find the answers to, and we investigate those, and that's what physics is about. And so we develop some structure or way to quantize a situation so that we can evaluate it, and that's the mathematical reasoning. We formulate some kind of mathematical problem. Once we've done that, we identify the steps that we need to solve the problem to answer the original question. And then finally, we use our computation skills to solve the math problem. But computation is sort of the last thing that happens. These first steps are much more important. I hope this short series that we've had, I hope it has made you feel somewhat better about the math and the work that we're going to do in physics. I'm excited for us to get started, and we'll proceed to one-dimensional kinematics soon.